Hi guys, my name is Srivalsan Manur and I'm software engineer working in the IT industry for the last 10 to 13 years. And the reason why I'm actually creating this video is I've been reading this book from Chip Huyen, which is quite an amazing book called The AI Engineering. And upon reading that book, I thought a lot of people does not have time to kind of uh, read a technical book. So why not make a video which talks about what is covered in each and every chapter, so that everybody can get a gist of what's covered in the book. So there's one way to do it, which is now we have LLMs out there which can actually just generate the snippet of what the book kind of talks about. But rather than that, what I thought is, why not make a series of videos where each and every video talks about each and every chapter and then goes in details of what's being covered in the book, what being covered in the chapter, what's the necessary topics which is being covered, and then go details about it. So this is going to be the first video where I'll be probably covering a certain section of chapter one, and you will also find a series of videos in the coming weeks where I cover the rest of the chapters. So moving on. So chapter one in the book talks about the introduction of building a application. So the book, the first chapter kind of gives a pretty good insight of what AI engineering is, what language models is. Like it kind of covers the basics in a much greater essence. So if you kind of really look at if you're in the LLM world or in the AI engineering world, I think why scaling AI becomes really necessary is because of two factors. One is the models are becoming more powerful and more capable, and training LLMs require much more data and compute. And I guess that's where the emergence of model as a service kind of started. And what the book then talks about is it moves on to the topic of rise of AI engineering. Why did we have a sudden rise in AI engineering? Multiple factors into it. One is essentially boils down to the language model. So, and then it kind of talks about what is necessarily a language model. We talk about language model quite a lot, but what is necessarily a language model? So, language model, as part of the book, what it states is that it's actually statistical information about one or more languages, and the basic unit of a language model is token. Now, what do we really mean by a token? It could be a character, it could be a word, or it could be part of a word as well. And the process of breaking text into a token is essentially called as tokenization. That's where you hear uh, the language model is talking about tokens. And so it's the process of kind of breaking the text is called as tokenization. And the set of tokens in a particular model that kind of tells you what a model's vocabulary is. Now, I think the first question which kind of comes to your mind if you're not too familiar with language model is that why do we need to use token if we can actually use words, right? So if I say my name is Shrivals and Manu, and probably I could just use one word as one token. Now, the reason why language models use token instead of words is that the token allows the models to break it into meaningful components, and it is much more efficient than using words. And what it also, the most important thing, what it also tends to do is it helps to process the unknown words as well, because when you're kind of going down to the words section, so if you're using tokens, it kind of really helps you to process unknown words. Now, then it kind of details into what are then the types of language models. Now, there are pretty much two major types of language models which is there. One is a masked language model, and then two is an autoregressive language model. So, what's a marked language model? Marked language model essentially figures out the missing token using the context before and after tokens, which is if you look at the sentiment analysis, or if you look at tax classification, or if you look at code debugging, what it's essentially trying to do is identifying the token based on the context of the series of tokens. It tries to figure out what is the missing text, or what's the thing which needs to be filled up, or trying to understand the sentiment of the text. Now, as against the autoregressive language model, essentially predicts the next token in a sequence, you based on the preceding token. So all the GPTs, force, and the OpenAI models, or the Chat GPT, for the perfect example, is a use case of text generation where it is an autoregressive language models. Now, if we just take a step back of, if you're going back to the machine learning world, we do have supervision. So, how many types of supervision are there? So, if you really look at it, the supervision has got you have supervision, self supervision, and unsupervision. Now, uh, what is these data is required for the supervision is your supervision needs label data. Your self supervision means the label data is actually inferred by the model, and unsupervision does not really need any labels at all. And looking at this in the context of the language model is essentially self-supervised. So if you look the input sequence, which is an input text, you have labels in which the tokens are to be predicted, and then you also then have the context which the model figures out, the context is actually used by the model to predict the sequence of tokens. Now, then the book kind of talks about the chapter then talks about the segregation of models. What are the different segregation of models out there? So obviously you have the natural language processing models, which essentially works on text and text alone. So the use case could be translation, spam detection, etc., where purely the model works on text. Then you have computer vision, wherein the model works only on vision, which is uh, object detection or image classification are all the use cases where these models are used. And then you have the audio only model, where the main context is actually the audio. So, for example, speech recognition, speech synthesis, all of those are use cases for audio only model. Then you have multimodal. Now, what do we really mean by a multimodal is it contains more than one data modality. What I mean by that is multimodal could basically take text and vision as input, or text and audio as input, or an image and an audio as input. So it basically works more than one data modality. So that's where a multimodal kind of comes in. Now, then probably the chapter then talks about what essentially is a foundational model. So what a foundation model uh, does is it's basically capable of a wide range of tasks, and it makes it cheaper to develop AI applications, and your time to market is actually reduced because of the foundation models. And essentially, the rise of foundation models led to AI engineering. So what you can then do is, once you have the foundation model, then you can tweak the foundation model to suit your needs, and that's what led to the whole AI engineering, which we are currently seeing. So, what do we really mean by AI engineering? So the process of building applications on top of the foundation models, that's essentially called as AI engineering. Now, there are three major factors which led to the growth of AI engineering. One is general purpose AI capabilities, which is currently brought to the market, and we do see quite an increased AI investments right now because of the rise in AI engineering, and building AI applications is now a low entrance barrier due to the development of foundation models, which is out there. Building AI applications is a very low entrance barrier as before, where you don't have to really build the models, where you can actually adopt the foundation models and then build applications on top of it. Now, that then comes down to what are the use cases of foundation models. So there are major 8 use cases. I'm not probably going into the details of each and every use case, but the first use case is coding assistance. There are quite a lot of coding assistance which is actually based out of foundation model. Then you have image and video production. You have writing as a use case where you can actually generate more content. Then you have education. You obviously then have conversational bots, informational aggregation, data organization, and workflow automation. So these are the major 8 use cases which is out there for foundational models. The chapter kind of goes a lot more detail in terms of what each and every use cases. But what I would really kind of found it interesting is the chapter then talks about how do we plan building an AI application, which is like, let's say if we have to build an AI application, what are the criteria which we need to kind of look at in planning an AI application. So what the author kind of talks about is there are four major criteria which you kind of need to look at in planning an AI application. First is use case evaluation. So you need to make sure that you evaluate the use case. And second is setting the right expectations. And third is milestone planning. And fourth is maintenance. So these four, irrespective of whichever AI applications needs to be built. So these are the four major factors which needs to be considered in building any AI applications. And probably in the next video, I will go a lot more in details about what the author talks in terms of each and every factors in building an AI application. Thanks a lot, guys.